All right, guys, we're starting chapter 3.4 now. Now, this section may seem annoying and pointless to a lot of people. So before we start, I want to kind of build your motivation to why we're doing it. The spirit of this section is really guess and check possible answers. Okay? And that's going to be what we're doing. Sometimes there's going to be 4 answers. Sometimes there's going to be eight, not 4 answers, but 4 things to choose from. Sometimes 8 things to choose from. Sometimes 12, 16. And even in some cases on the homework, there might be some with 24 cases to choose from. And from those, you might only need 3 or 4 answers. And you have no way to know which answer is right, which answer is wrong, and it's going to be pointless. You might be thinking, why can't I just memorize a formula or something that will get my answers real quick? Why do I have to do all this guess and checking? So before we start, I wanted to kind of give you a little motivation for why we're doing this. So what we're doing is we're basically finding zeros of polynomials. Oh, gotta zoom in. Okay. Now, the zeros of a polynomial is basically just your equation equals 0. You do some solving, and in the end, you end up with x is equal to, and then whatever the answer happens to be. So that's the idea. And that was a big topic in math a couple hundred years ago. So anyway, we're going to start with the easiest of polynomials. Well, not the easiest, because that's just a number. But we're going to start with a degree 1 polynomial. And this one's kind of a no-brainer. A degree 1 polynomial is just a line. And a line is mx plus b. You set that equal to 0, and this one's so easy that we don't even memorize it. We just do the 2 operations. You just subtract the b over, and you divide by m. So if for some reason you wanted to memorize the answer to the x-intercept of a line, there you go. That's my 0. All right? I want you to notice a trend here. Now we're going to move to degree 2. Now, degree 2, this is a quadratic. Or you can think of it as x squared. But anyway, so the general formula for this is ax squared plus bx plus c. Set that equal to 0. And again, there's going to be solving involved. And we did a little bit of it in chapter 3.1, but there's solving. And this was way back in the, I want to say 1400s, but I'm probably wrong. Probably earlier than that. But anyway, mathematicians want to say, can we come up with an answer for it? And it's an answer that we all know and love. It's the quadratic formula. Negative b plus or minus square root b squared minus 4ac, the whole thing divided by 2a. Okay, so that's degree 2. And notice that with the answers, let me get different colors. Notice we have one solution. Here we have 2 solutions. So there seems to be a trend, and we're going to see if the pattern continues. It's degree 1, 1 solution. Degree 2, 2 solutions. All right. Another thing to point out is look how much more complicated the problem got. This one is the happiest of answers, and you just move over 1 degree. So 1 degree higher, and the answer just doesn't get 1 degree harder. The answer goes from happy to bleh. So your face for this one might be all happy rainbow. And here, I mean, I like it, but I know a lot of you are kind of like, ugh, where you know how to do it, but you'd rather not. So that was solved. We have an answer for the x-intercepts. And mathematicians, being mathematicians, don't want to stop there. We said, all right, well, what about degree 3? This is a cubic. And here we have ax squared plus, no, sorry, not ax squared, cubed. Ax cubed plus bx squared plus cx plus d equals 0. And again, a lot of the solving here, about 300, 400 years ago, this was basically the problem of the decade, problem of the year, however you want to think of it. People were trying to solve it, and they were trying to figure it out. And it wasn't just like college students, like the brightest brains in math were trying to figure this thing out. How can I get an answer? What is it? X is equal to what? And the reason why they were slowing down is because this little guy wasn't invented yet. Okay? So if he wasn't invented yet, it turns out that you can't solve the problem. There was no imaginary numbers. And because of that, people would do solutions. They would work out solutions, and then they'd end up with the square root of a negative. Remember, if you square root both sides, you get I is equal to the square root of -1. I'm just using the positive version. Okay? And in their math, they would get that, and they would stop. They'd be like, oh, that can't be done, so this must be wrong. And they would start over and do other things. But it turns out that no, that's okay. Now people would say, you know what, I'm just going to roll with it and see what I get. But then they'd publish, and then all the other math people would get angry because there was a square root of a negative. They didn't want to accept it. But anyway, it was eventually accepted that this is a thing. And let's look at the answer. So I want to show you the answer real quick. There we go. So notice that this answer is really, 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 really nasty. I have 3 solutions, x1, x2, x3. And also notice that there's the imaginary number. This is what was stopping people from solving the problem. But we got 3 answers. And notice how nasty that is. So would you rather guess and check with 8 or 12 possibilities, or would you rather try to memorize that formula for an exam? And hopefully the answer is you'd rather guess and check, because yeah, ain't no one want to do that. But the answer does exist. So if we go back to our paper, the answer does exist, but it kind of makes us sad. Now, while they were solving the degree 3, it turns out that people said, you know what, I'm going to skip it, and I'm going to solve the degree 4 instead. This is a quartic. And this equation is ax to the 4 plus bx cubed plus cx squared plus dx plus e equals 0. And it turns out that they actually had it solved, providing that the degree 3 solution existed. So that they work through it and they say solved, but there was a little thing by that said only if degree 3 solution exists. And so they were kind of at a bump in the road. There's my degree 3, I have the answer. There's the degree 4. We technically have an answer, but now it's being held up by the one that we can't solve. So eventually, once degree 3 was solved, they were both solved simultaneously. So let's look at this answer. So going back over here. Dun, dun. So I'm zoomed in a lot. That's why this thing's really huge. But I'm going to hide my tools. And notice the answer. It's 4 solutions. And notice that it goes on. 4 different solutions or 4 different rows. And look at my toolbar. Got a lot of room left. I always imagined the original Star Wars where the Imperial ship's following Leia's ship. And it just doesn't end to show how mighty the Empire was. But look at that. That's nasty. So a solution does exist, but look how nasty it is. Very, very, very ugly. Okay? So, yeah, ain't no one want to memorize that. Okay, so hopefully you now see that rather than memorizing a formula, we're instead going to guess and check. It makes life much easier. The only formula I'm going to memorize is this one. Okay, because that one does come in handy. But everything else, don't memorize it. Just go with the guess and check method. Now, they did prove that anything degree 5 and higher, there is no formula. And it's not that they couldn't find it. They actually proved that a formula doesn't exist. Anyway, let me pause my video real quick, and then we can start this next section. All right, we're back. So anyway, let's get started with this section. So the first thing was we need to create our list of possible answers. So remember, the idea here is we're guessing and checking. But what are the possible answers? Well, that's where this theorem comes in. This theorem creates my list. Okay, so this is where I said you have 4 answers, 8 answers, 12 answers, 16 answers to choose from. This is where those answers come from. And what the theorem is saying is, I'm going to try to zoom in here. If we have our equation, and let's say the first term is ax, I'm going to say cubed, or you know what, I'm going to say to the 5th, why not? Plus, and then there's a bunch of terms here. And then we have, I don't know, wait, 5, 4, 3, 2, 1. Okay, do basic math in my head. B, C, D, E, and F. Okay, so anyway, what they're saying to do is they're getting the number, this number, and they're getting the very, very last number. And they're giving them special names. I don't care about the middle. So actually I can erase this plus EX because we don't need him. All right? So if you have a polynomial, you get your first number and your last number, and we give them names. Now, it's kind of counterintuitive. You see that they're going to be called P and Q. And you think, oh, P comes first, so it must be the first one. Nope. It turns out that this one is my P. Okay? And to avoid all this letter confusion, you know what? I'm just going to say last term. So this ends up being just a number. And this last term has to have no x's in it. All right, but anyway, so you get that, and you're going to call it P. Now the first number, instead of calling it A, we're going to get that, and we're going to call it Q. Okay, so P is equal to the last term, and again, there has to be no x in it. And then Q is equal to the first leading coefficient. So I want to do some examples to kind of get you the idea of how we're going to create our list. All right, so let's do this. Use the rational zero theorem to list the potential rational zeros of 2x cubed minus 5x squared plus 8x minus 6. So I have no idea what the answers are, but I noticed that there's the last number and a first number. So my P is equal to the last number, which is negative 6, and Q is equal to the first number, which is 2. There's no x's in these things. You just need to take just the numbers. And so what we're going to do is after you figure that out, you're going to do factors of the last number, over factors of the leading coefficient. So what are the factors of negative 6? So the factors of negative 6 are plus or minus 1, comma, plus or minus 2, comma, plus or minus 3, comma, plus or minus 6. So these are the numbers that fit into. So remember, when they say factor, they mean numbers that fit into negative 6. So 1, 2, 3, and 6 are the only numbers that fit into 6. Now I can go to 2, and the only numbers that fit into 2 are 1 and 2. And so what you're going to do is you're going to list every combination. So every numerator, you're going to pair with the number in the denominator. And you list all the possibilities. So usually what I do is I start with my first number. And I'm going to be using my eraser a lot, so you might not want to write this down. But so we get this first number, and I'm going to pair it with those two numbers. So I have plus or minus 1 over 1, which is 1, plus or minus 1 over 2, which is 1/2. And then we move on to the next one. Now I move to this one. Okay, 2 over 1. 2 over 2. 2 over 2 is 1, which I already have. So I can now move on to the next one. 3 over 1, plus or minus 3. 3 over 2, plus or minus 3/2. Okay, erase that. And then I move on to the next one. So this is plus or minus 6. 6 over 2 is 3, but I already got it. And so there's my list. I have created 1, 2, 3, 4, 5, 6. There's the plus or minus of each one. So I have 12 possible answers to choose from. So that is the rational zeroth theorem. It gives us a list to choose from. And again, the reason why we're using this list is we don't want to guess and check. We don't want to use the formula because the formula is really evil. Now, if I go to Desmos and graph this guy, we're going to actually solve it in a bit. But if I go to Desmos and I graph this, so f of x equals 2x cubed. I already forgot what the formula was. 2x cubed minus 5x squared plus 8x minus 6. All right. So there's our formula. And notice that this is just a cubic. I'm going to make x go from negative 5 to 5. And so there's my line. I notice it does have an x-intercept. And the x-intercept is that number. Actually, did I get it right? 2x cubed. I got this one from the book. Minus 5x squared plus 8x minus. All right. So I got this one from the book, and they probably didn't want you to graph it. But anyway, notice this number. And this is actually a good point. That number notice that it's not on the list. So there's a little like what if thing kind of going on here. This 1.231 isn't on the list, and there's no other answer. So what does this formula mean? What just happened? So I have 12 possible answers to choose from. So what they're saying is that if the answer is a fraction, and remember, whole numbers are fractions. It must be in the list. Okay, but that's a big if. So if the answer was a nice answer where it's a fraction or a whole number, it has to be in this list of 12. But it doesn't say that the answer must be in there, as the example that I just showed. Okay, notice that that answer is not there. So the solution isn't a fraction or a whole number, so it doesn't have to be in the list. Anyway, that's kind of funny. I won't do that to you in class though. Every problem we do, at least all but 2 are going to be in the list. And the very last 2, you're going to have to use the quadratic formula to figure out. Anyway, on the homework, you're going to deal with problems where all they want you to do is list the possibilities. All right, moving on. So I have 3x to the 4 minus 2x cubed plus 9x squared minus 5x plus 12. So they say list all the possibilities. And so remember, the last number goes on the top. It's kind of counterintuitive. So we're going to do factors of 12 over factors of 3. Well, 12 is a dense number, which means it has a lot of numbers fit into it. 1 fits into 12. 2 fits into 12. 3 fits into 12. 4 fits into 12. 5 doesn't, but 6 does. And then the next number is 12 itself. And then 3, 1 fits into 3, and 3 fits into 3. So now I have to list every possibility. So again, I'm going to keep these 2 on the bottom. And all I'm going to do is I'm going to hop around on the top. 1 over those 2 numbers. Then I hop to the next one. 2 over those 2 numbers. Hop to the next one. 3 over those numbers. 4 over those numbers. Then 6 over those numbers. And then finally 12 over those numbers. If you get a repeat answer, you don't have to write it again. So if I start with the 1. 1 over 1 is 1. 1 over 3 is 1/3. Okay, we're done with that one, so we move on to the next one. 2 over 1, 2 over 3. Done with that one. Go to the next one. 3 over 1. Then 3 over 3. 3 over 3 is 1. I already have it. Go to the next one. 4 over 1. 4 over 3. 6 over 1. That's plus or minus 6. 6 over 3 is 2. I already got it. And then finally 12 over 1, which is plus or minus 12. And 12 over 3 is 4, and I already got it. So here's my list. Now again, that's 1, 2, 3, 4, 5, 6, 7, 8, 9 times 2. This is 18 possible solutions. And again, if, and that's the big if an answer is a fraction, and remember whole numbers are fractions, it must be in that list. Okay, math breaks down if that's not true. Math is a lie. No. Okay. So let me actually try to graph this one. 3x to the 4 minus 2x cubed. I'm going to laugh at both of them are like that. 3x to the 4 minus 2x cubed plus 9x squared. Minus 5x plus 12. Right? Oh god, look at this one. It actually has no x-intercepts. All the answers are imaginary. Oh, that's fine. Anyway, again, I won't do that to you in class. when we're doing these problems by hand, you're going to guarantee that you have some x-intercepts. But if there was an x-intercept that was a fraction, it would have to be in that list. All right, so that's the first page. Now let's go over some stuff. We've covered this before, but not really very briefly, but no, not very briefly. We haven't covered this before. All right, so how important are polynomials? So important that this theorem is called the fundamental theorem of algebra. Meaning out of the entire topic of algebra, math people decided to congregate and say this theorem is the most important theorem, the fundamental theorem. And it's pretty boring. If you read it, it just says every complex polynomial has at least one complex zero. Basically, all this sentence means, I'm going to put this in layman's terms. If it has an x, if the polynomial has an x, it has an x-intercept. And that's the fundamental theorem of algebra. That's it. If the problem has an x, it has an x-intercept. Now you can piggyback off that, and I'm going to kind of do my example. Let's say you're dealing with a degree 3. Well, a degree 3, does it have an x in it? Yes. So then I can factor that x out, whatever the answer happens to be. And if I factor it out, I'm left with a degree 2. Does degree 2 have an x in it? Yes. So I can factor that out. And I'm left with a degree 1. Does a degree 1 have an x in it? Yes, it does. I can keep on going. This line I'm drawing is just a blank. X minus blank, x minus blank, x minus blank. And then you're left with a degree 0 at the end. Bad, Gilbert. I ran out of room. The explanation of that went a lot better in my head. But anyway, so this is a degree 0. And does that have an x in it? No, it does not. And so this idea leads to the corollary. And notice that it was degree 3 to begin with, and we had 3 answers. It turns out that there's a pattern there. So if you include multiplicities, a polynomial of degree n will have n complex roots. So if it's degree n, then equation equals 0 has n solutions. And this is what usually people refer to when they're talking about the fundamental theorem of algebra. They're talking about the piggyback. If you have a degree n polynomial, you already know how many answers you have. And that's useful. If you know how many answers there are, it kind of, you know when you're done, you know if you need to keep looking. But anyway. And from this, we also get this theorem. Notice that I had this, and then degree 0 is just a number. And that's identical to what this is. This is just written more formally. Okay. The linear factor theorem says because we can always factor out something if it has an x, every polynomial can be written like the following. And all this is a is my leading coefficient. We're going to be doing examples in a bit. And all this is x minus my x-intercept, or x minus a solution. I'll say x-intercept, but you know, it's a 0. X minus x-intercept. X minus x-intercept. And you can keep on doing that, x minus x-intercept, for however many x-intercepts there are. If there's 3 x-intercepts, you can do that 3 times. If there's 2 x-intercepts, you can do that 2 times. And so this is the linear factor theorem. So before we start, let's do some happy problems. And my phone's kind of buzzing at me and blinking at me, so let me pause the video again. All right. So this first part, I know I'm throwing a lot of information at you. This together, these two ideas combined is a lot of info. So let's kind of break it down by doing some problems. How many zeros, including multiplicities, do the following polynomials have? And you're going to see problems on the homework that are just this happy. Notice that this is degree 7. So it has 7 zeros. Remember, zeros are solutions. So it's like you're saying 7 solutions. Seven solutions to equation equals 0. So if you were to create this problem, they would have 7 answers because the degree is 7. 3? Nope. I fell for my own mistake. So it's not always the leading term. The first term isn't always the leading term. Remember, the degree is the highest exponent. So this one has 9 zeros. The highest exponent here is 1034. So this has 1034 zeros. That's it. The degree is the number of answers that you're going to have. So, our first problem. Find the smallest degree polynomial with these answers. Assume a leading coefficient of 2. All right. So, the linear factor theorem what it says is your polynomial is equal to blank, x minus blank, x minus blank, x minus blank. And how many zeros? Well, they said find the smallest possible. And so if it has to have 3 zeros, then the smallest would be degree 3. 3 zeros, 3 answers. What goes here is my leading coefficient. That goes in the front. And here, this is just an x-intercept. Here, this is just an x-intercept. And here, this is just an x-intercept. So I'm going to go ahead and plug those in. Negative 2, 3, 5. And my leading coefficient was 2. So tidying that up, f of x equals 2, x plus 2. I don't like that plus sign. X minus 3, x minus 5. There you go. And so that's all I want. On the homework, they might make you factor it out, but for me, you don't have to factor it out. And if they make you, you can always go to a website and have the website factor it out, because that's just for what we're doing, that's just busy work. The main idea here is that you're able to factor it. So I'm going to type this in Desmos. X plus 2, x minus 3, x minus 5. So I have 2 x, I already forgot it. You think plus 2 minus 3 minus 5. Okay, there you go. And notice answer, answer, answer. Let me get the thing here. Okay, so there you go. I created a polynomial and it has those 3 solutions. Now, if you wanted to, again, you can. I like Wolfram Alpha. That's just my choice. So if the homework makes you, and if you want to build up your skills, you can kind of do it by hand, but ain't got time for that. So this is x plus 2, x minus 3, x minus 5. Hit enter. And it shows you some stuff, and one of them should be the factored form. There it is. 2x cubed minus 12x squared minus 2x plus 60. I already forgot. Gilbert short-term memory is bad. Minus 2x plus 60. So again, maybe the homework. Maybe not. But this is all I want. All right. Let's keep chugging. So now that we've kind of formed the basics, we have this whole page of bleh. And so let's go over the page of bleh. So when you're guessing and checking, sometimes you might have like 84 possibilities to choose from. And well, theoretically, you could have a lot of possibilities to choose from. And you don't want to actually do that. So this upper and lower bounds for zeros, it helps you eliminate possibilities. Okay. So let's say you're doing synthetic division, because we're going to be doing synthetic division to see if it's an answer or not. So, for instance, I'm just making something up. Let's say we have 4, and you have all your stuff on the inside. You do your synthetic division, and you end up with all positive answers the entire way through. Okay? If that happens, then that means that this number has to be an upper bound. And what that means is you eliminate all answers equal to and greater than that answer. Or not even equal to, all answers greater than, because it could be a solution. So eliminate all possibilities larger than 4. So that's what you would do. And it's a very useful theorem. So when you're doing your guess and check, if you realize that you have all positives with your synthetic division, you can eliminate a lot of questions. Now, a lower bound, you'd think that it'd be the opposite, where it'd be all negatives, but it's actually different. If it alternates. So if you're dealing with this and it alternates, plus, minus, plus, minus, plus, or minus, plus, minus, plus, minus, plus, then that means that you have a lower bound. Notice it alternates, it alternates. And so, for instance, if I was doing 4, or let's say we're doing negative 4, and you were doing your synthetic division, and you ended up getting that pattern. Okay? Then what you would say is you would say eliminate all possibilities lower than negative 4. So they're useful theorems. Sometimes if you're dealing you can have like 84 possibilities, and once you find an upper bound, you can eliminate like 30 of them right off the bat. Okay, so that's just a thing to speed things up. But here's what we're going to do. Here are the steps. The beast. Finding zeros of a polynomial. So use the degree to determine the maximum number of zeros. So how many answers do we have? Okay. If f has all integer coefficients, and in this class this will always be true, not in general, but for 13, 14. No. No. So always true for 13, 14. I'm not going to be mean to you like that. What you can do is you can make your list. So you figure out how many answers they have. You make your list of possibilities. Okay. And then you guess and check. This is where you start doing synthetic division. Now, why are we doing synthetic division? Because if you use a number, and again, I'll just use 4 as my example. Let's say you get numbers here as your answer, but sometimes what you're looking for is you're looking for a 0. Okay? And that means that it's an x-intercept. So you're basically guess and checking by doing synthetic division until you get 0 as an answer. This is what you're looking for. Okay? Now, if it's not a 0, then you're going to cross it off your list and you move on to the next one. If it's not a 0, you cross it off your list, you move to the next one. All right, my cat jumped on the table. All right. Once you find out that it's an answer, you can factor it out. And then you repeat the process with the quotient. And the quotient is always going to be 1 degree smaller. So the idea is you're making the problem smaller every time you find an answer. Okay? Once you get it down to a quadratic, kill it with a quadratic formula. So I've just been talking. This is where everyone goes to sleep. So let's go and at least start an example. Okay. Now this one's really easy. It's just 2x squared plus 5x minus 3. And so the first part, now I can do this by hand, but I want to show you the idea. So, and this is exactly how it's going to look like on an, well, I can't say it's going to look like on an exam because it's going to be an online exam. But if it weren't for social distancing, this is what the question would look like on the test. Okay. So the first question would be, find all possible rational zeros. So this is where you create your list. So you get your last number, you get your first number, and you're going to do factors. Remember, the last number goes on top. So here, the only factors of 3 are plus or minus 1 and plus or minus 3. The only factors of 2 are plus or minus 1, plus or minus 2. So if we make all possibilities, okay, and so here we have 8 possible solutions. Okay, and I'm pretending that I can't just do the quadratic formula, but what you would do next is, since you have 8 possible solutions, this is where you start the guess and check. So, the guess and check, it's up to you. If you like, you can gamble and say, oh, that 3 is calling out to me. I'm going to pick it. And you want to try that first, go for it. I usually just go in order until I find it. So I'm just going to start with 1 because I'm boring like that. So we have C equals 1. I'm going to try it out. I put the 1 there. I do synthetic division. Now my number is, remember we're using the original equation, so 2, 5, negative 3. Draw the line underneath. And my goal is, I'm hoping to get 0 at the end. 2 times 1 is 2. 7, 7, 4. All right. And so notice that it's not 0. So I cross it out. So that means that 1 is not a solution. But also notice that all of these are pluses. So this is actually an upper bound. We can eliminate all answers greater than 1. So this means all answers greater than 1. There's 2 of them. If I look at the list, there's 3 and 3/2. So plus 3 and plus 3/2 I can cross off. All right, so 3 of them down, 5 to go. Let's try -1, because why not? So if I do -1 and I just repeat the process, I have 2, 5, -3. So I work this out, and I get 2 times -1 is -2, 3, and then 3 times -1 is -3, -6. Notice that that is not an answer. Close, but nope. It's not alternating, and they're not all positive, so I just eliminated that one. I can move on to the next one. So in my list would be 1/2. And this is all you're doing. This is the guess and check. Very repetitive, very boring, but it's good times. Builds character. 2 times 1/2 is 1. 5 plus 1 is 6. 6 times 1/2 is 3. So this means that 1/2 is a solution. Now, this was degree 2. That means that there's 2 solutions. So since there's 2 solutions, I already found one, 1/2. I got to find the other. And so now what you do is you get the quotient. And you don't keep guessing when it's that easy. So your quotient is now what you're using. So this is 2x plus 6. All right. And notice there you can factor the 2 out, and you get 2 times x plus 3. And so looking at that, we have the other answer is -3. But I want to show you the process. So let's say I didn't know that that was really easy to factor. The idea here is after you get an answer, we start using the quotient forever, and you keep going on. What you would do is you would say, well, maybe 1/2 happens twice. So I'm going to try 1/2 again. But this time I'm going to try it with the quotient. You never go back to the original problem. 2 times 1/2 is 1. 6 plus 1 is 7. And so, yep, that doesn't work. So 1/2 is gone. Now, just in hindsight, I know the answer is -3. So eventually you would keep guessing until you get to -3. And when you work it out, notice that you get the 0 you're looking for. Okay, and so -3 is a solution. The final number that's left, there's only one number left, and notice that that's the leading coefficient. So my answer is f of x is going to be equal to x minus x minus All right. So my leading coefficient is 2. One answer is 1/2, and the other answer was -3. So I go ahead and write it a little nicer. And there's my solution. Okay, so I am aware that this problem could have just been done with a quadratic formula, but this is the idea that we're going to do. Well, I'm going to fill in that table in a bit. Okay, you list your possible zeros. You guess and check using the upper lower bound stuff if you can. Once you get an answer, you don't use the original problem anymore. You start using the quotient. And then you keep guessing until finally you get down to the end. Now for us, we're going to get down to a quadratic and use the quadratic formula. But yeah, That's about it. Now let me go ahead and fill in this table. The zeros were -3 and x equals a half. The multiplicity of each was 1. They happened only one time. The behavior at the 0, since it's 1, they cross. And then when I say flatten, I use a different terminology this time. When I say flatten, I mean, does it do the x cubed thing? Remember, the x cubed thing is when it crosses, does it cross like that? And so here, the degree is 1, and so the answer for these is no. Okay, so if the multiplicity is 1, it crosses like a straight line. This is just a recap from last time. If it's 2, it touches. Again, that's the parabola. If it's 3, it's going to cross like a cubit. Okay. So since these were degree 1, they cross like a straight line. So no, they don't do the cubic thing. All right. There you go. So let's do an actual problem. So here there's actually this is a long section too. So let's keep chugging. I need to take a water break. All right, guys, take 5. All right, break time's over. So this next problem is similar, but this is more like what you're going to see in class. So they say find all possible rational zeros of f of x. So let's look at the last number, the first number. So I'm going to take all factors of -1. I'm going to divide it by factors of -2. Factors of -1 are plus or minus 1. Factors of -2 are 1 and 2. Now this one's happy because notice it only has 4 possibilities. Oh, nice. I put this on a test a couple years ago. Because if you were taking this in class, I'm not going to make a huge list where you have to guess and check forever. So once you have your list, there's 4 possible fraction solutions. And again, this is only if they're fractions. And in this class, all but 2 are guaranteed to be fractions. Okay. So I know I'm looking for 3 answers because my degree is 3. I have 4 things to choose from, and being lame, I'm just going to go left to right. So I'm going to start with 1. And I put the numbers of the polynomial, -2, 5, 0, -1. And I work it out. -2 times 1 is -2, 3, 3, 3. 2 times 1 is 3, 3 minus 1 is 2. So do a quick check to make sure I did that right. Yep. And so notice that they don't alternate, they're not all positive, so all I can eliminate is 1. So 1's not it, 3 more to go. So I'm going to go and try -1 now. So -2, 5, 0, -1. So -2 times -1 is 2, 7, -7, -7, and -7 times -1 is +7, 6. So that's not it because it didn't end in 0. And notice that they alternate, meaning that since they alternate, this is a lower bound. But if you look at your answers, it's already the lowest number. So that doesn't really help us. Okay? Basically what I mean is if you put the possibilities in order, it's -1, -1/2, 1/2, and 1. So basically what we said is -1 there can't be any answer smaller than -1. Well, there isn't. So, went, went. So I go to the next one. Let's do 1/2. And so I got -2, 5, 0, -1. My cat really wants me to pet him. He's lying on my table, belly up, just looking at me. -2 times 1/2 is -1. And so I said this to the other class, and they were like, oh, why didn't you say that before? Multiplying by a fraction is pretty easy. You just multiply to the numerator, divide by the denominator. -2 times 1 is -2. Divide by 2 is -1. 4. 4 times 1 is 4. Divided by 2 is 2. 2 times 1/2 is 1. And there you go. There's your 0. And so we got that as an answer. So we finally found an answer. Trying to keep everything in my scheme as I was doing it. And whenever you find an answer, you go to the quotient. This becomes my new problem. Okay? Never go back. To the original. Okay? So I want to see maybe 1/2 happens more than once. Because remember, the multiplicity can be 1, 2, 3 for our class. So I'm going to try the 1/2 again. But this time I'm not going to use the original. I'm going to use -2, 4, 2. So -2 times 1/2 is -1. 4 minus 1 is 3. This becomes 3/2. And notice that that is definitely not 0. 3, 4, 5, 6, that's 7/2. Okay, so that's not it. Now, the only answer that I have left to choose from is -1/2. Now, -1/2, -2, 4, 2. -2 times -1/2 is +1, 5. -5/2, that's 2 minus 2.5 is -1/2. That's not 0. And so we cross it off. So how many answers did we find? We only found one answer. Only found one solution in the list. Okay. Now, since we only found one solution, are we done? Basically, here, I know that 1/2 is an answer. I know the multiplicity is 1. I know that it's going to cross. It doesn't, remember, does it look like the x cubed? And so the answer would that be no. But remember, we have 3 solutions. 3 of them. So I only found 1. So the question is 2 are missing. Oh no. And this is where I wrote the if. If they are fractions, they have to be in the list. That means the missing 2 answers are not fractions. And so to find the last 2, I'm going to make everything smaller so I'm back up on the top of my page again. But to get the last 2, the only way to get them and get the exact answers is we're going to have to do the quadratic formula. 'Tis the only way. Why is my... Sorry. Technical difficulties. There we go. All right. So basically what we do is our new problem was -2x. So we had -2, 4, and 2 was the quotient that we were left with. I can turn that into negative 2x squared plus 4x plus 2. And remember, we're setting that equal to 0. And so here we just do basic math. I can factor negative 2 out. And I have my answer. So a is equal to 1, the number in front of x squared. B is equal to negative 2. C equals negative 1. And so my problem, remember we use the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4. A times c is just negative 1. And then the whole thing divided by 2a, which is just 2. So I end up with this as my last two answers. So 2 plus or minus square root of 8 is 4 times 2. 2 plus or minus 2 square root of 2, because the 4 turns into a 2. Over 2. And then you divide each one by 2. So 1 plus or minus square root of 2. You don't have to show that many steps. I just wanted to be really clear of what I was doing. But anyway, these are the last two answers. They're not on the list. There was no way to find them without using the quadratic formula. Okay? So what we're going to do in this class is we're going to go all the way until there's 3 numbers left. We're going to guess and check until the quotient has 3 terms. And then we're going to use the quadratic formula. That's all we're doing. That's really tiny. And I apologize that my handwriting's kind of all over the place here. I had a lot to write and I kind of got separated. But that's all we're going to do. That's basically this section. You get a problem, you guess and check until there's only 3 terms left in the quotient. Once there's 3, rather than keep on guessing and checking, we can say, oh, well, that's a quadratic. Let me just finish it off. And you write it out as a quadratic, use the quadratic formula, and you get your final 2 answers. So 1 plus square root of 2, 1 minus square root of 2. And these happen one time. They cross because they only happen one time. And since they only happen one time, they're not cubics. So, yeah. What happens here is that if you don't know what you're doing, it's easy to get lost. A lot of people get overwhelmed by the blank page when they see this. And this is every step, you have to get it to where every step makes logical sense, or else you're going to get lost in what you're doing. But anyway, the last thing is write f of x in terms of linear factors. So remember, linear factors is x minus x minus x minus Okay. My answers were 1/2, and then 1 plus square root of 2, 1 minus square root of 2. Technically, these are in parentheses, but you're going to see that it doesn't really matter. And then the leading coefficient goes here. And in this case, the leading coefficient was negative 2. So your final answer is negative 2, parentheses, x minus 1/2, parentheses, x, if I distribute that, minus 1 minus square root of 2, minus 1 plus square root of 2. There you go. And you factored it. So you had a problem that was nasty, but because you found the x-intercepts, you were able to successfully factor it. Yay! All right. So to keep chugging, we're almost done. 2 more pages, guys. 2 more pages. Stay with me. Let's go to these 2 theorems and put in the last little bit before we're done. So the next one is called the irrational pairs theorem. And I kind of made up that name, to be honest. But it just means that for the problems that we're doing for our class, you're never going to see that by itself. Whenever you see that, you're always going to have that with it. They come in pairs. All right? And the same thing applies with imaginary numbers. So for our class, whenever you see a plus bi as an answer, a minus bi has to also be a solution. So if you do the next example, it says find a polynomial of smallest degree with real coefficients, a leading coefficient of 1. So they tell us what the first term is. That means it's going to be 1 times x minus blah, 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 blah. And zeros of 5, multiplicity 2. So that means that 5 happens twice. And negative 4 plus I. But because what we just said, you have negative 4 minus I has to also be an answer. So if you think about it, we actually have 4 zeros. There's 1 0, there's the other 0, and then 5 happens twice. So there are going to be 4 answers. So I need to make room for them. So it's going to be f of x equals blank, x minus blank, x minus blank, x minus blank, x minus blank, and let's do it. So they're showing a show on Cartoon Network's Adult Swim right now that they showed back when I was like in high school, and it makes me feel really old. Anyway. So, they told me my leading coefficient is 1, so I know the number in front is 1. I know that 5 happens twice. And I know this is negative 4 plus I, negative 4 minus I. And again, you distribute the negative. So the final answer, to make it look pretty, multiplying by 1 doesn't do anything, but x minus 5 happened twice. So this is x minus 5 squared, x plus 4 minus I, x plus 4 plus I. So hopefully that wasn't too bad. We have our answer. 5 happened twice, and then you have those 2 imaginary answers. Now again, in the homework, if they make you FOIL it all through, for our class, it's not really required, but just for fun, because Gilbert likes fun, I'm going to show you a trick on how to multiply these 2 imaginary ones. Usually people see those last 2, and they get freaked out, but think of it like this. You have x plus 4 is its own thing. minus I, x plus 4 plus I. And so if I FOIL this, thinking of it like that, so if I FOIL, x plus 4 times x plus 4 is x plus 4 squared. X plus 4 times I, negative I times x plus 4. And then finally, minus I squared. So I just expanded it using the FOILing technique. So negative I times I is minus I squared. And this makes life a lot easier, because notice that the two terms here cancel each other out. And you end up with x plus 4 squared minus I squared. That's x squared plus 8x plus 16 minus I squared is negative 1. And so you get x squared plus 8x. 16 plus 1 is plus 17. All right, so we call the first one linear factors because each parentheses is degree 1. Now this one down here is linear and quadratic factors because the second term has a quadratic in it. Now again, on the homework, I don't remember which one they do. On the test, I'm fine with linear factors. So for me, for Gilbert, this is all Gilbert wants. Because you understand the concept, you know what you're doing, and life's good. On the homework, they could say linear and quadratic factors. If they say linear and quadratic factors, they mean they want you to get the two terms with the I in it, and they want you to expand them. Okay? Now, if you go more than that, and they want you to FOIL the whole thing out, then you can just go to Desmos, because ain't no one got time for that. So x minus 5 squared, x squared plus 8x plus 17. And you're going to get this huge answer. All right, there it is. I'm not going to write it down, but there you go. And that's what you would write in. So if they want you to expand it, you would write all that in. Really nasty. Or the homework could say, write it in linear and quadratic factors, which means they want you to turn the i's and they want you to FOIL the terms with i's in them. Or they'll say linear factors, which is the one I want, where it's just using this formula. All right. Next one. Find the zeros of x cubed minus 8x squared plus 25x minus 26. And before I start this again, let me do one last pause.